Section 4.4 is trig functions of any angle. So we've mentioned before that positive angles are counterclockwise rotated. Negative angles are rotated clockwise. But now we have a couple new terms. The reference angle is an acute angle, so it's less than pi over 2, formed by the terminal side and the horizontal axis. So earlier when we were kind of mapping some problems in the xy plane, technically, right, if the angle was originally measured from over here, the reference angle is the angle in that same quadrant that gives you the same values, right, as the original angle. So it's easier to work with the triangle than it is to try to memorize, right, what this is all the way around the circle. Coterminal angles are angles that share the same coterminal side. But what that also means is they also have the same initial side. So it means if I start from the same position, right, and I rotate around, whenever I'm stop rotating, I stop at the same terminal side as I would as the other angle. So let's look at how to find the reference angle for each of the following. So 11 pi over 6. So if I draw, first thing I want to do is I want to find out, well, where is the angle located? And I always assume that the original angle was being measured from the positive x-axis. So one way to help out with doing this is look at the denominator of your angle. And it's easy to count which quadrant you're in by converting that denominator. So here's what I mean. The denominator is 6. So I know that on the unit circle, this is pi over 2. But pi over 2 in terms of 6 is 3 pi over 6. This is usually pi. But if I convert that to a common denominator of 6, well, that's 6 pi over 6. This is usually 3 pi over 2. But if I convert that to a common denominator of 6, I multiply this by 3 over 3, and I get 9 pi over 6. And then if I'm back at 2 pi, well, that's going to be 12 pi over 6. So why is this helpful for me? Well, 11 pi over 6 isn't a known angle on the unit circle. But now I can clearly see, well, I got to go past 3 pi, past 6, past 9, and it's somewhere right in here. So another way you could have thought about this was you could have said, well, 2 pi over 6 is 12 pi over 6, so I got to go almost but not quite to 2 pi. So I find the denominator rule to be helpful just as a check. So if I draw this angle, it's basically here. So I'm in quadrant 4. The reference angle is the angle between this terminal side and this axis. So it really wants to know what is the little piece that's left. So when you draw it out, you can see, oh, I almost go all the way around the circle, but I'm just like this much shy of finishing the rotation. So we can say that 2 pi minus 11 pi over 6, well, that's the same thing as 12 pi over 6 minus 11 pi over 6. So my reference angle is just pi over 6. And reference angles are always positive. Let's look at how to do 317. So once again, I'm going to draw my quadrants. This one's a little easier because we know this is 0, 90, 180, 270. So 300, oh, and then we're back at 360. So 317, right, we got to go all the way around, right, and stop somewhere in here. So there's 317 degrees. So once again, I'm in quadrant 4, and I can see that I'm this much shy of making the full revolution. So this is the reference angle, right? It's between the terminal side and the x-axis in that quadrant. So to calculate this, I can say, well, I go 360 degrees, subtract off the 217, and 43 degrees is what the sliver left over is.